Right now, as you watch this, something is forming in the Equatorial Pacific that will reshape the European winter of 2026-2027. The ECMWF models have already predicted it. NOAA has already issued the alert. And what they're seeing is an event that happens only a few times in a generation, and which the last few times it occurred left Europe under snow in October, cities paralyzed by cold in November, and heating systems collapsing in the middle of January. At this very moment, surface temperatures in the central Equatorial Pacific are rising at a rate that climatologists rarely see. A Super El Niño is emerging, and the chain of consequences it sets in motion doesn't begin in Europe, but it will end there, in full force, in the coming months. In this video, you'll understand exactly what's happening in the Pacific, why it matters to people living in Lisbon, Warsaw, Stockholm, and Athens, how the polar vortex fits into this equation, and what climate models are projecting for the fall and winter of 2026 and 2027. No speculation, no doomsday scenarios, no tabloid headlines, just the physics, the data, and what's really at stake for 240 million Europeans who will spend the next 6 months relying on systems that may not be able to withstand what's coming. Before we continue, if you've ever experienced an unusual winter, a cold snap that hit when it shouldn't have, or an unexpected snowstorm, share your story in the comments. Not your opinion, but your story. Where you were, what happened, what you saw. This community learns from those who've lived through what the models sometimes fail to capture. If this channel provides what you can't find elsewhere, subscribe now, not as a favor, but because when the models update in the coming days, you'll want to be the first to know. And if this video reaches 8,000 likes, I'll be back with a full update when El Niño peaks, with the final figures and what national weather services are reporting internally. To understand what's coming, you first need to understand where it all begins. Kilometers away from Europe, in the middle of the Equatorial Pacific, in a stretch of ocean that runs from Peru to the Philippines and acts as the planet's climate thermostat. There's a distinction most people don't make, and it's fundamental to everything that follows. El Niño isn't a storm, it is not a hurricane, it is not a discrete event with a visible beginning, middle, and end. El Niño is a state, an anomalous condition of Pacific surface temperatures that lasts for months, alters atmospheric pressure patterns on a global scale, and sends ripple effects to every corner of the planet with a delay of weeks to months. When NOAA oceanographers speak of a Super El Niño, they are using a precise classification, a sea surface temperature anomaly of more than 2.0 degrees Celsius in the Niño 3.4 region, sustained for at least 5 consecutive months. This is not just a strong El Niño, it is a different category of event, comparable to the El Niño of 1997 and 1998, which was the most intense of the 20th century, and to that of 2015 and 2016, which broke historic global temperature records. The NOAA Climate Prediction Center, the CPC in College Park, Maryland, published in July 2026 probabilities that rarely appear in its reports with such clarity. A more than 70% chance that the developing El Niño will reach strong category status before the end of the Northern Hemisphere fall, with a peak window between November 2026 and February 2027. The ECMWF, the European Center for Medium-Range Weather Forecasts, which operates out of Reading in the United Kingdom and runs the highest resolution models available in the world, confirmed this trajectory with its own ensembles, and what its analysts are seeing in the temperature anomaly maps for the December, January, February quarter is not reassuring. Now, most people hear El Niño and think of drought in Australia, rain in California, and hurricanes in the Pacific. Europe doesn't make that intuitive list, and that is exactly why what's coming next is so dangerous, because Europe isn't immune. It's at the end of the chain, but when the signal arrives, it hits hard. A senior climatologist affiliated with the ECMWF, who asked not to be identified because his comments go beyond what official statements currently authorize, said something that stuck with me when I spoke with him earlier this month. In his words, "What concerns us isn't El Niño itself. It's the overlap. We have a strong El Niño over an Atlantic Ocean and a Mediterranean Sea that still hold the accumulated heat from a record-breaking summer. When these two anomalies interact, the models produce outputs that have no clear historical precedent, and that means the margins of error are greater than we'd like to admit publicly." That's what the official figures don't say. Uncertainties exist. They are greater than the official statement suggests, and experts know this. 240 million Europeans will spend the coming winter relying on heating systems, energy infrastructure, and transportation networks designed for historical averages, and those historical averages may not be the correct benchmark for the winter ahead. That's the context. Now let's turn to the physics. The difference between an El Niño that goes almost unnoticed in Europe and one that paralyzes entire cities does not lie in the Pacific. It lies in what happens at the top of the atmosphere, 30 kilometers above the ground, in a structure that most people have never heard of, but that determines whether your winter will be mild or brutal. The polar vortex is a system of high-altitude winds that circulates around the Arctic during the winter, keeping cold air confined to the north. When it is strong and stable, it acts as a barrier. The Arctic cold stays in the Arctic, and Western Europe experiences mild, wet winters. When it is weak or disturbed, it fragments. And when it fragments, the Arctic cold has no barrier. It descends. And Europe feels it. The mechanism linking El Niño and the polar vortex is indirect but well documented. A Super El Niño excessively warms the tropical troposphere. This warming propagates upward and toward mid-latitudes via Rossby waves, planetary disturbances in atmospheric circulation. These waves reach polar latitudes and weaken the stratospheric polar vortex. The weakening of the stratospheric polar vortex precedes, with a delay of 2 to 8 weeks, the collapse of the tropospheric polar vortex, what meteorologists call sudden stratospheric warming. And when that happens, the circulation pattern over Europe changes radically. Severe Weather EU, the independent meteorological service that produces some of Europe's most respected medium-range forecasts, published an ensemble forecast in July 2026, showing a probability of over 60% of at least one sudden stratospheric warming event during the winter of 2026-2027. To put this in context, the winter of 2020-2021 saw such an event in January, and Europe experienced extreme cold from Portugal to the Baltic in the weeks that followed. The winter of 2010-2011 had another. So did 1987. The pattern is consistent enough to be predictable, not with certainty but with sufficient probability that energy and public health planners need to act now. The difference between knowing this 4 months in advance and not knowing it is not merely academic. It is the difference between a healthcare system that has prepared extra hospital beds, secured stockpiles of medications for respiratory illnesses, and trained response teams, and a system that was caught off guard. And this is where the story gets more complicated because Europe is not the same everywhere, and it is in these disparities in preparedness that deaths occur. Consider the contrast. Finland and Sweden have building codes that require sufficient thermal insulation to withstand temperatures as low as minus 40 degrees Celsius. 80% of Finnish homes have access to some form of district heating, centralized systems that do not depend on each household having its own equipment up and running. When the polar vortex hits Helsinki, the system absorbs the shock. Greece, on the other hand, which has spent decades with mild Mediterranean winters, has a housing stock in which 35% of properties in Athens lack adequate insulation. Electric heating is the norm, and when the temperature drops below zero and the entire city turns on the heat at the same time, the power grid collapses under the demand. That is exactly what happened in February 2021, when a polar cold snap hit Greece and left entire neighborhoods in Athens without power for hours. It wasn't a lack of weather forecasting, it was a lack of infrastructure. And that infrastructure hasn't changed in the 5 years since. The difference between Helsinki and Athens isn't latitude. It isn't the severity of the cold that strikes. It's what societies have built to withstand what physics inevitably delivers. This should be a lesson Europe has already learned. It hasn't, at least not uniformly. The vulnerability map for the winters of 2026 and 2027 has layers that need to be understood separately because the risk is not the same everywhere, and knowing where you stand on this map is the first step toward knowing what to do. On the Iberian Peninsula, Portugal and Spain face a specific combination of risks. The summer of 2026 left the soils of inland Iberia in a state of severe water deficit. The Tagus and Douro reservoirs are below 60% of capacity in July, according to data from Portugal's National Water Resources Information System. A cold, dry winter, which is the pattern historically favored by El Niño in southern Europe, could exacerbate this deficit and lead to water restrictions lasting into the spring of 2027. AMET, Spain's state meteorological agency, has already issued monitoring bulletins, but the precipitation figures projected for the December-February quarter are consistently below the historical average in medium-range models. In France, the risk centers on two factors. First, the nuclear power system, which supplies 70% of France's electricity and underwent an accelerated maintenance period in 2025 and 2026 following years of technical problems. If an extreme winter arrives with peak demand for electric heating while reactors are undergoing maintenance, France faces a capacity shortfall that could force it to import energy from neighbors who will also be under pressure. RTE, the operator of the French power grid, published a supply security analysis in June 2026 that identifies precisely this scenario as the highest risk one for the coming winter. Second, rural populations in the Massif Central and the Alps, where entire communities depend on mountain roads that become impassable in heavy snow, and where the supply chain for food and fuel can break down for days. In Germany, the energy situation is different but equally tense. The accelerated transition to renewables has created a grid that, on days of high demand and low wind generation, exactly the kind of weather a polar anticyclone brings, relies on imports and gas reserves that are at levels below what is desirable following previous winters. The Bundesnetzagentur, Germany's network regulatory agency, monitors gas storage levels weekly and issues warnings when reserves fall below 80% in October, the threshold considered necessary to get through a severe winter without supply cuts. In the Netherlands and Belgium, the primary risk is different: flooding caused by rapid snowmelt combined with heavy rain. The Dutch Delta Works is one of the most sophisticated engineering projects in the world, but it was designed for tidal and storm events, not for inland flooding caused by extreme precipitation in inland watersheds. The city of Liège in Belgium was devastated by floods in July 2021, and adaptation efforts are still underway. A winter with successive periods of snowfall and rapid thawing could trigger this risk before protective measures are fully in place. In Central and Eastern Europe, Poland, the Czech Republic, Hungary, and Slovakia, vulnerability stems from a combination of outdated heating infrastructure, which relies on district heating networks that are decades old and have not been modernized quickly enough, and low-income rural populations that lack the capacity to stockpile fuel or adapt rapidly. Poland still burns coal in a significant fraction of its homes, and the cost of coal during extreme winters rises sharply, creating an access dilemma for lower-income families. But what comes after winter is where the chain of consequences expands in a way that standard news coverage rarely addresses. And this is where the story gets really complicated. The first level of consequence is the most visible: deaths from hypothermia, overwhelmed hospitals, and paralyzed transportation systems. In winters with sudden stratospheric warming, Europe has recorded spikes in excess mortality, deaths above the expected average for the period, reaching tens of thousands in a matter of weeks. The winter of 2017-2018, which included the phenomenon known as the Beast from the East, an influx of Arctic air fueled by a fragmented polar vortex, was linked to more than 25,000 excess deaths in the United Kingdom and Western Europe. According to an analysis by the European Centre for Disease Prevention and Control, this is not a projection. It is what historical data show when the pattern being projected for 2026 and 2027 materializes, but that is not the end of the chain. The second level of consequence is less visible but equally serious: what happens to healthcare systems after the peak. Hospitals that operated at full capacity for weeks, treating cases of hypothermia, respiratory illnesses, and falls on icy surfaces, emerge from the winter with longer surgical waiting lists, depleted medication stocks, and exhausted staff. The schedule of elective surgeries that was suspended during the winter crisis is added to the end of a waiting list that already existed. Cancer patients wait longer. Heart surgeries are postponed. The health impact of an extreme winter does not end with the winter. It lingers for months. The third level of consequence is economic and political, and it is what climate models do not account for, but what historians of past events clearly document. Extreme winters affect productivity, increase energy costs for households and industries, strain the public budgets of countries already operating on tight fiscal margins, and create political tension that translates into votes. Parties that exploit fear and a sense of abandonment gain traction during periods of energy crises and heat waves. This is not speculation. It is the pattern that has repeated itself following the harsh winters of 2010, 2012, and 2018 in several European countries. And the fourth level of consequence is what connects this winter to the following summer, and closes a cycle that most people do not see. A cold, dry winter in southern Europe, which is the most likely scenario according to the models, means that reservoirs will not recover during the rainy season. Spring 2027 begins with a water deficit. Summer 2027 begins with dry soil, and dry soil combined with heat is the perfect environment for large-scale wildfires, like those that devastated Portugal in 2017, Greece in 2018 and 2021, and southern Europe in 2022 and 2023. The heat cycle that seemed to end with the fall may be setting the stage for the next summer disaster. The chain has no clear end. It has links. So, what can you do with this information now before fall arrives and winter begins to loom? The honest answer is more than you think and sooner than you imagine. If you're in Europe or have family in Europe, now is the time to check your heating systems before demand for technicians skyrockets in October and November, not in September. Now. Check the condition of the insulation on your windows and doors. Have a plan B in place if the main heating fails. a secondary heating method, even if it's a portable electric heater, for the room where your family spends the most time. Make sure your older neighbors have what they need and know who to turn to if they are without power for hours. Download the app for your country's national weather service, Meteo France, Germany's DWD, Spain's EMET, Sweden's SMHI, and turn on alert notifications. These alerts arrive before the situation becomes an emergency. Take advantage of them. I'll be closely monitoring the evolution of the Equatorial Pacific indices over the coming weeks. NOAA's ONI index and the ECMWF ensembles are the two most important indicators. When the models confirm the peak of El Niño or show a significant change in trajectory, I'll be back with an update. And when the first short-term winter forecasts start appearing from national weather services in September and October, that'll be the subject of my next video. This community has been following these events with a level of seriousness that few channels receive from their viewers. I read the comments, learned from the real-life experiences you share, and am impressed by the quality of the discussion that takes place here. That's why this channel exists, not to deliver headlines, but to provide insight. Share this video with anyone in Europe who will be spending the coming winter at the mercy of weather systems that may be tested in ways they haven't been in years. An early warning can be the difference between being prepared and being caught off guard. Take care. Stay tuned to what the models are saying and see you in the next one.